So in preview today is the Hyperscale Premium Series hardware. This is a hyperscale tier specific hardware. They're newer generation CPUs, and they're faster than what was the customer facing Generation 5 or standard series hardware. So there are two flavors of this. The first one is Premium Series, which scales up to 128 vCores, has the same memory to core ratio, 5.1 gigs per vCore, and has the same price point as the Generation 5 Service Objective. So in effect, this is very similar with the difference of being newer generation and faster CPUs. And in addition, these are great for OLTP workloads. In addition, we have the Premium Series memory optimized offer, which offers 10.2 gigs per vCore memory to core ratio. This scales up to 80 vCores, and this is great for analytic hybrid workloads or any workloads really that require extra memory, have those resource intensive queries. Now, this is at a price premium given you get significantly more memory per vCore. And then we are announcing this in preview. So the early preview limitations are that it's in limited regions. We will now demo this Azure Hyperscale Premium Series hardware using HammerDB and compare the performance between Generation 5 versus the Premium Series hardware. We're going to launch HammerDB here on a 32-core instance. So this is going to ramp up, and we'll look at the transaction counter for TPM as a metric, right? The workload is ramping up. We see that it's already at 6,000, a little over 6,000 batch requests per second. And if we look at transactions per minute, we are in the 373 or so mark. Right, and so this should settle down in a bit. So first thing we do is we look at the slow or the service objective. We are on Gen 5 32 vCore, and the next thing we are going to look at exposing you to a DMV. It's Resource Governor Workload Groups History. This gives you the name of all workload groups from internal to user to others, and a bunch of statistics around that. This is taken at a snapshot interval. So you see total CPU, delta CPU, you get IO, memory, and a bunch of other metrics around that. So zooming into a user workload group, which is called user primary group, we'll look at delta CPU usage because it's a CPU bound workload, and we can see that CPU milliseconds per second is in the 15 seconds time frame. So that's 15 seconds per elapsed second, indicative of 15 or 16 CPUs being used totally. Looking at names of workload groups, you see a bunch of them. Not all of them are user. A lot of them are internal workload groups. So aggregating CPU across all these workload groups, we see a total of 22 seconds of CPU per elapsed second. So that's 22 cores out of 32. That's roughly around 80% of CPU being used. Right. So if we look at kind of the TPM, we are still at the 383 mark, and this hovers between 350, 355 to 385. Somewhere around there, you'll see it stabilize. So looking at metrics, batch requests per second are in the 6,000 range, a little over 6,000. And it's pretty much stabilized. You look at transactions per second, they are more in the 20,000 range. And so we'll stop the workload and now switch our hardware to the new series. Right, so we go to compute and storage, we change configuration of hardware, and we're going to see two new premium series offers. One is premium series, which is 5.1 gigs per core, 128 vCores. We choose that. The other one is the memory optimized that we're not going to use in this demo. So we flip to 32 vCores to match up previous Gen 5 offer, and we scale the database up, which is generally very quick in the sub-minute range that scale up happens. So we'll start our workload on the premium series. If you have to specify via CLI or T-SQL, HSPRMS32 is the service objective. We can check the database service objectives and see that this is scaled up to HSPRMS32, which is 32 vCore offer. And then we'll flip back to kind of our usage. First thing you'll see is batch requests per second is already at the 8,000 mark. right? And if we look at transactions per second, um, we are upwards of 500,000, right? And CPU on the left is at the same 60%, though it's the same number of vCores. You have 60% of CPU and a little over that of instance CPU. That includes the internal workload groups, right? So you have 60% of user CPU and about less than 80% total CPU. And batch requests, and it's still ramping up to some extent, as you can see from kind of batch requests per second, but it should settle somewhere a little north of 8,000 batch requests per second. So again, looking at our workload group stats, the user primary group still uses about the same 16 cores, 16 seconds of CPU per elapsed second. Um, and then so it's the same amount of cores, yet you get newer generation hardware and less throttle. And then across all the workload groups, again, you see the 22 cores, which are roughly around 80% of CPU usage of the 32 cores that exist. So coming back to TPM, we are at the high 514,000 mark. We were at 350 to 375 versus 514,000. Coming to batch requests, we have solidified this at a little over 8,000 batch requests per second versus and 26,000 odd transactions per second. If you looked at the Gen 5 chart, we were closer to 6. It's still 32 cores, but we were closer to 6.1 thousand batch requests per second, and the transactions were 17.9 thousand. And across this, your log latency or write latency has been sub 2 milliseconds, other than the momentary spike above 2 milliseconds. It's been an average of 1.62 milliseconds of commit time log latency. This concludes this demo. As we have seen, running HammerDB on Premium Series, we've got upwards of 500,000 transactions per minute versus closer to the 375,000 transactions per minute on Generation 5, which is a big performance boost at the same price point as Gen 5.